So if you recall, last time we had discussed kind of the foundations of Java 8. I talked a little bit about the so-called object-oriented paradigm, which I'm expecting everybody sort of knows. If you don't know what object-oriented programming is in Java, this class is going to be rather mystifying, at least at first. So I'm assuming you sort of know the basics, like what's a method and what's inheritance and what are parameters and stuff like that. And then I gave you a quick summary of some of the stuff in Java 8. And I talked about functional programming. And I tried to kind of compare and contrast functional programming with object-oriented programming. That had a few examples, but it was fairly high level. What we're going to do now is we're going to start diving into the nuts and bolts of Java 8. And we're going to start out with something called Lambda Expressions and method references, which are two of the cool new features that are in Java 8. So I'll talk about Lambda Expressions. I'll talk about method references and constructor references. I won't say a whole lot about constructor references yet. We'll cover that in more detail in the next section. And I'll give you a couple examples to illustrate how these things work. You'll have to know how this stuff works in order to do part B of assignment 1. For part A, you just have to know the Java 7 stuff, but for part B, you'll have to know this. It's pretty straightforward, but it's very cool. And the key thing is it's the building blocks for all the later stuff we'll cover when we start talking about parallel computing, where it gets much more interesting. And you'll see why we use Lambda expressions and method references in order to be able to concisely express our stateless behaviors to these various streams and other capabilities for doing parallel computing. So let's start out with what is a Lambda expression. So a Lambda expression is an unnamed block of code which might have parameters depending on how it's defined. And this unnamed block of code can be stored, passed around, and or executed later. And we'll talk about what it means to be executed later in a second. In fact, the very first example we'll give is a good example of executing something later, and in particular in a different context, as we'll see. So that's what a Lambda expression is. And you can take a look at this link here for a nice overview of Lambda expressions to give you more context for this stuff. Here is the syntax. Lambda expressions have this kind of funky syntax. This particular syntax says, this Lambda expression takes no parameters. So open, close, paren, with nothing inside, just says this is a no parameter Lambda expression. I'll show you examples of parameters in a second. And then there's this arrow, and this basically says everything that follows the arrow up to the end of this phrase or this statement is the body of the Lambda expression. So in this particular case, what we're doing is we're going to define a computation which will print hello world in a background thread or from a background thread. First, quick recap. Does anybody remember what a thread is? Does anybody know what a thread is? Not even remember? What's a thread? So a thread is essentially a unit of computation that can run a stream of instructions concurrently with other threads that are running within a process. A process is just a unit of containment in which threads can execute. Processes provide certain resources like memory or a heap or protection from other processes, and within a process you can have multiple threads. We'll be talking about threads a little bit later, but just in a nutshell, a thread is essentially a way of running a computation separately. On modern operating systems, on modern multi-core processors, separate threads can often run in parallel in separate cores. So each thread would be mapped to a core, and then they could run in parallel. We'll talk a lot more about that. That's obviously a very important topic. But for right now, think about a thread as having its own runtime stack, and it has some computations. And when we make a new thread and we start it, which is what this example shows, it's simply going to print hello world, and that's the result of the computation. Any questions about that? OK. You can also store Lambda expressions in variables or fields. So here's an example where we're going to store the Lambda expression for system.out.println hello world in a local variable called r of type runnable. And then we can pass r to the thread constructor in order to start the thread to run that computation. So if you recall what my definition was, a Lambda expression is an unnamed block of code. in this particular case, it doesn't really have a name. I mean, we store it in a variable, but it doesn't have a name. You don't really have a name here for this thing. It's just the block of code. And we can store it. We can pass it around. We can pass it as a parameter to the thread constructor. And then it can be executed later. In this particular case, it's executed in a separate thread of control. Any questions about that? Hopefully that's pretty straightforward. Even if you don't know a whole lot yet about what a thread does, you can understand the concept of passing this unnamed block of code, which in this case has no parameters, to another object, in this case a thread object, and then doing something with it later. So that's basically the idea. Why are lambda expressions a win? The lambda expressions are a win since they're very compact or concise. And the reason that they're very concise is they only focus on the computation or computations to perform, and they leave off all the other extraneous syntax that otherwise is visually distracting and causes carpal tunnel syndrome. Right? So here's how you might have written that same sort of code back in the day prior to Java 8 by having to write what's called an anonymous inner class. And look at all the additional syntax we have to do here. We have to say new runnable. That makes an instance of this anonymous inner class. Public, void, run, bloppity, bloppity, blop. All that stuff that I have in red, except for system.out.println hello world, that's all just sort of syntactic vinegar. It's not syntactic sugar, it's syntactic vinegar, because it makes you do extra stuff. It's not very tasty. And so what you can see with the lambda expression in contrast is it just gets to the essence of the computation and doesn't distract you with all this extra syntax. So it's more concise, it's more compact. You can use lambda expressions not just with no parameter types like runnable, but you can also use them with multiple parameters. And you can do it in a way that's more compact than trying to program with these traditional anonymous inner classes. So here's an example of this. Let's say that we've got an array of strings with just people's names in there, and we want to find some way of being able to compare the strings in a way that ignores case. So in that particular case, I'm sorry, we're going to sort the array in a way that ignores the case. We don't care whether they're uppercase or lowercase. They compare them in a case-insensitive way. And you can actually get the code here in my ex1 folder in my GitHub repository. So, sort of the image here is this is the big Humvee. It's very big. This is a much smaller, more compact solution. So let's take a look at this solution. This is trying to provide an anonymous inner class comparator that compares two strings to see whether they're equal, less than, or greater to. And so what we have to do in this case is we say new comparator string, and we go ahead and have the compare method, which takes string s and string t, and then it returns s by lowercasing it, and then it compares that to t that's lowercased. So I think you'll agree with me that if someone gave you this code to maintain, you'd be like, what the heck is that? You'd spend a lot of time parsing through that code visually, trying to figure out what it does. In contrast, here is a lambda expression way of doing this. So what we do here is we say arrays.sort name array, so we're going to sort this array, and then we give a lambda expression. And notice how we say open paren s comma t close paren. This is simply indicating that this lambda expression expects two parameters, and what's cool about it is that the compiler can actually figure out that s and t are actually strings. So you don't have to write string s, string t. You can leave out the types. That's what's called type inference or type deduction. And the compiler can figure out what types these things are, which is good. And then all we do is we just say, hey, I want the comparison function to be s, parameter 1, dot compare to ignore case t, where t is the second parameter. So I think you'll agree with me that that's a lot more concise, and once you get used to the syntax, it's a lot easier to tell at a glance what this code does compared to that code, which is more verbose and takes longer to type. And you're likely to get a syntax error because it's a lot of extra work. Okay. And the reason why this is more concise is the lambda expression omits the method name. There's no name. There's no compare with parameters and all this gobbledygook. And all the extraneous syntax just evaporates, which is cool. Another interesting thing you can do with lambda expressions is you can actually pass values to them or pass variables to them as long as those variables are either what are called final variables or effectively final variables. Does anybody remember, you may or may not have learned this in your Java course, but does anybody remember what a final variable is in Java? What's that? Right, so once it's assigned, it stays with the value. It's very much like, if you're familiar with C++, the concept of a const, right? So const int I equal 10. You can't change the value of I. So final variables are basically the same kind of idea. Once they're set, you can't change them. There's also something that came more recently in Java called effectively final variables. And an effectively final variable is a variable that doesn't have to be final. So you see, like, int answer is in fact not marked as final, but it's effectively final because between the point where it's assigned the value 42 and where we actually access the value in the Lambda expression, it doesn't change. So it's effectively final. You can read more about effective final at the link here. So effectively final variables or final variables can be passed as parameters to lambdas. And what will happen is that even though this is actually going to run in a totally different context, right? This is going to run in a separate thread in the background. We can pass it a variable as long as it's final or effectively final, and that value will be used in the context in which it runs, which in this case will be a separate thread. Okay, any questions about the concept of lambdas? We'll look at a lot more examples as we go through this, and you'll get a chance to write plenty of code to use it, but I just want you to get the basic idea. All right, second concept, method references. You'll see that a method reference is a compact, easy to read handle for a method that already has a name. And as we'll discover as we go through the course and you play around with your interactive development environment, there's a nice relationship between Lambda expressions and method references that can often be automatically converted by your interactive development environment, which is kind of cool. There are four main types of method references. One is a reference to a static method. So if you have some class, like say string or whatever, you can then say : static method name. And this is very much like, if you're familiar with C++, the concept of static member functions or static methods in C++. That's basically the same, almost identical syntax and the same basic concept. We're referring to a static method. You can also have a reference to an instance method of a particular object. So if we have a given object, we can refer to an instance method. An instance method is simply a non-static method, right? That's what it is by default. You can also see here that we can have a reference to an instance method of an arbitrary object of a given type. So we can have a method named of a particular type. And finally, we can also have a reference to a constructor, which is called a constructor reference. Surprise, surprise. You can read more about the concepts here in the link down below. I'm going to give you an example here of a reference to an instance method of an arbitrary object of a given type. So in this particular case, we don't care which object it is. The object will be inferred from the context, but it has to be of a particular type. So if Lambda expressions are compact, what are method references? Well, they're even more compact. And by the way, if you ever want to have some fun, there's actually a motor vehicle museum out by the airport. I think it's called Lane's Motor Vehicle Museum or something like that, Lane's Car Museum. And it's out by near the airport. And they've got all these old cars, really fascinating. And some of the cars actually look like the cars I'm showing you here. They're really tiny, compact cars meant for, living in crowded European cities like Rome or whatever, because you can find parking more easily. And here's an example that kind of illustrates what I'm talking about. Remember, this was the verbose, anonymous interclass way of doing a comparison when doing sorting. Here was the more concise or more compact Lambda expression version. And then finally, right, again, car metaphor going down here, the super duper compact method reference version, where we say string : compare to ignore case. So that's really compact. And what I was mentioning before is your IDE, if you're using Android Studio or using IntelliJ or whatnot, it will be able to go back and forth between this representation and that representation. It'll do the transformation for you automatically when you click a button in your IDE. It's really cool. It's a good practice to use method references whenever you can. And the easiest way to do this is to write your code with Lambda expressions, and then oftentimes the compiler will say, oh, you can automatically convert that, or I will automatically convert that for you into a method reference. And why is that? Because if you look at this code, it's easy to tell at a glance we're going to sort the name array using a comparator that ignores case. Right? You can just do an easy left to right scan of that. It's really obvious what's going on, very concise, no carpal tunnel syndrome, easy on the eyes, no muss, no fuss. Okay, so let's take a look at some examples here. So one thing you can do with method references is you use them to do things like print collections or print arrays in various ways. So assuming we have our name array with various names, we can print this out in a couple different ways. One way to do it is to use the system.out println method. So you can actually print out an array, and what we're going to do here is we're going to call println to produce this result, except what we're first going to do is we're going to convert the array into a list. So there's actually a factory method, a helper factory method called asList, which comes from the arrays class, which is called a utility class. And this returns a fixed size list backed by the specified array. So it's going to be a list of things that correspond to this. The reason why we have to do this conversion is that println doesn't know how to print an array, but it does know how to print a list. So we just convert the array to a list. Pretty straightforward. We can also print things other ways. So we could use Java 8's for each method. And you'll see there's a couple different variants of that. And we can use this to print out the values of an array. So here's one way to do it. We can take our name array, which is this guy here, and we can convert the name array into a stream. And we'll talk more about streams later. The of method on a stream is a factory method that creates a stream from an array. You'll see there's lots and lots of these factory methods that convert from one thing to another in Java. So we convert name array from an array into a stream, and then we call the for each method on the stream, which is, as we'll see later, a so-called terminal operation, which will then perform the action that's passed in as a parameter on every element in the stream. And in this particular case, we do system.out : print. So system.out is going to refer to an object a class. Right? It's an object. It says an object here. And then we're going to go ahead and print that particular, we're going to print the value of each element to the screen. And that'll produce this output. You can also do something similar, except now we could convert the name array to a list using the asList method we just looked at, that factory method. And then we're going to call for each on each list element. So remember before, we'd done this on each element in a stream. There's a for each method on a stream, and there's also a for each element on a list, which actually comes from, I think it's from iterable, which is an interface way up the hierarchy of collections in Java. And that will also do the same thing. It'll print the results. You might ask the question, why are there two different ways of doing for each, and are they actually the same? And so this is a topic we'll cover later in the course, but it turns out that there's subtle differences between for each on a stream and for each on a collection, like a list. They're just a little bit different. You can read more about that here if you want to know the nitty-gritty of it. But in a nutshell, the ordering for operations on a stream is not defined if you call for each on a stream, and I'll explain why in a second, whereas it is defined on a collection. For a collection, it's basically sort of a left to right ordering as it's iterating. It's the iteration order on a collection, whereas for a stream, it all depends on what kind of a stream it is. In particular, if it's a parallel stream, then the ordering of for each could be non-deterministic. I'll explain why when we get to talking about parallel streams later. The way to think about it for the moment is, in a parallel program, as a general rule, if you don't have to enforce an order, it can often run a lot faster. Whereas if you do have to enforce an order, it may take longer to run because you have to make sure that things show up in the right order. So we'll see that one of the big benefits of parallel computing is non-determinism, because it allows the system to optimize the way in which things execute, thereby potentially speeding up the program's runtime performance or scalability. So we'll come back to that later. One other little point I want to mention here, and this is a little bit more of an advanced topic, but so I'm just going to talk about it briefly. Using lambda expressions allows you to implement a variant of something called closures. So if you take a look at this particular link, EX1, you'll see the program I'm demonstrating here. And this is an example of closures. So that obviously raises the question, what is a closure? So a closure is a method that has an environment with at least one bound variable. And you'll see in this particular case, we're going to be creating something in here that will act as a closure. And in particular, it's this make thread closure is a factory that creates the closure. If you want to learn more about closures, take a look at the link down here from Wikipedia. So here are the ways in which you can pass variables into closures, and in particular, what is a bound variable. So as you'll see here, this parameter s of type string, this parameter n of type int, and this private field int with the name mres for mresult, those are all examples of so-called bound variables. And so we're going to be able to use those bound variables in the context of a lambda expression. So notice that this method, make thread closure, creates a thread that is going to have these variables bound into the lambda expression that's part of the thread that's being created. All right, so let's take a look and see how this works. Oh, and you can also see here, by the way, that what we're going to do down here is we're going to call make thread closure, which is calling that factory method. And we're going to pass in the string that we want to give and the initial value n. And then what this thing's going to do is it's going to, in a separate thread of control, it's going to print the string, and it's going to increment mres by n. So it's going to read n, and it's going to update mres. I'll explain that more in a second. So remember, a bound variable is a name that has a value, like a number in this case. The value 10, for example, would be a bound variable to n. So this lambda that you see here implements a closure that captures the private field and the method parameters. And when this code gets run, we'll get a thread back here. We can start the thread, we can join the thread, and those values will have been captured and can be used inside of that lambda expression. Interestingly enough, and this is really weird, not weird, it's just hard to remember, private fields of a class can be updated in a lambda. You'll notice how we can increment mres by adding n to it. However, parameters like s and n, or local variables, which we don't have in this case, are only readable. So we can't update the parameters, we can't update the local variables, but we can update private fields. This is a bit of an advanced topic. I'm just mentioning it here because people sometimes get excited about the fact that you can pass variables to the lambda expressions, and they say, oh, that's great, they're closures. And they are sort of closures, but they're not the full-blown closures you would get with a pure functional language. You can read more about the limitations of closures in Java 8 in this article at the bottom. We're honestly not going to do a whole lot more with closures in this class. I just wanted to mention it to you because people sometimes think about this in the context of Java, in Java 8. Okay, so that's essentially the end of the overview of lambda expressions and method references. Do not despair, we will have lots and lots and lots more examples as we go through the class. So if things are a little mysterious, they will get clear if at no other time, but when you actually use these things when you write your programs. Then it'll become really clear.